Good morning, everyone.
Good morning, Mukesh. So just wait for 1 minute. We'll start, okay? Yes.
Okay,
All right. So good morning, you all. Right, and welcome to SDWAN session. Right. So let's start our session today. Okay. So I hope you all are doing great. Right. Am I audible? Can someone confirm if I'm audible?
yes,
Okay.
Yes,
Good.
you are clearly audible.
Thank you so much. Thank you so much, guys. So let's start. All right. So in yesterday class, we had just a basic fundamental discussion about the SD-WAN, how this SD-WAN revolution started, and then basically SD and software-defined network revolution started, and then how different components through like the multiple vendor that introduced like the Cisco, like we having the SD-WAN, SDXS, and also we have the ACI, right? So these are all three components, but we are just focusing for the SD-WAN solution. And after that, we understand some key basic advantage of the SD-WAN. But I told like we just have to do the deep dive, and we just have to correlate how this is basically going to give the additional edge, additional benefits over the traditional WAN while using the SD-WAN. And also we try to discuss some basic curriculum detail where we just discuss what all we are going to cover throughout this session, and after completing this course what level of knowledge you guys are going to get, right? And some we done discussion about the lab part, right? How the lab is going to be accessed and how this can be configured from the scratch. So from zero we'll configure this lab, right? And we try to understand the hardware model and how this physical connectivity is going to happen for the devices when we are going to use the SD-WAN solution, right? So these all basic fundamental we discuss in yesterday class, that was again open class, and today again that is going to happen very basics, because once we very good with the basics, then only we able to understand some core concept, advanced concept, complex concept, right? So basic is very important. You just have to understand the terminology, right? How things is going to be deployed, how things is going to work, how it is going to be new for the you for the entire learning. So how you are going to correlate with the old infrastructure. So that's why the basic understanding the new technology is very important. So the more focus for the initial class is the theoretical steps, which is the more basics, more deep dive about the technology components and the working style. So let's start. So we in today's session we try to understand what is SD-WAN, right? What is SD-WAN in continuation of the study class, right? So we understand the first part, the SDN evolution, how it was happen, and then SD-WAN come in a picture. But we just have to understand what was a traditional WAN and how SD-WAN come in a picture and how it is going to overcome that all problem which is associated with the legacy WAN. So what was the problem with the legacy WAN? That is the your business ready WAN. You can told about the old WAN or normal like the wide area network connectivity. So you can see we having a lot of kind of the problems in the legacy WAN. So we having the problem that is the complex operations. So we can see here we having the complex operation. In addition of that, we having the cost is very high, right? So complex operation, higher cost, limited scalability, like no crowd app readiness, fragmented security, we having a limited application awareness, right? We having the insufficient bandwidth and disjoint solution. So we'll try to explore these all problems and how it is going to be give extra edge while using these all benefits. So let's understand how this basically legacy WAN was working earlier, right? And this is like your new WAN, like the Cisco WAN architecture. So we'll try to understand. So in legacy WAN, like let's say suppose you want to deploy a legacy WAN solution. So traditional WAN was designed to route a traffic from the remote site to any company data center using the private MPLS circuits, or might be you can use the some internet-based circuit that could be the based on the IPsec. So the first statement I'm saying, traditional WAN which you use, that basically going to route a traffic to your data centers by using the private circuit, could be the MPLS or could be the IPsec circuit that is based on the internet. However, the new requirement, the new business application are not only hosted in the data centers. They start hosting in the some public clouds like such as the Microsoft Azure, Amazon Web Service, Google data center as well, Google Cloud as well. So now you think, let me just draw some diagram so you guys can visualize. Let's suppose this is my, let me do something. Hemant DS. Just give me 1 second, guys. Hemant DS. Harmeet, you able to hear me?
Yes, we were here.
Okay, you trying to write something, Harmeet? Let me. Just give me 1 second, guys. Okay, so now we are good. Right. Okay, so let's start. Sorry for a little bit interruption here. So I was telling, let us suppose I have the one data center. So this is my data center location. Just think about this. Let me use this level of the pan. So this is my data center, right? So you can add data. So this data center, right? And this data center is going to be connected with a various branch location. So this could be my branch BR1. This could be the BR2. This could be my BR3, right? So how this data center connectivity is going to be happen? So there could be the one cloud. We can think this is my MPLS cloud, right? This could be my MPLS cloud, and just wait, guys. Someone is trying to do something.
अरे एल्विस भाई के सामने कोई बोल सकता है क्या? एल्विस भाई,
Just give me 1 minute, guys. Some naughty people are here. Just okay. So I just for time being I just unmute remove the unmute part for the everyone. So if you guys having any question, just raise your hand because some people are trying to do some disturbance. So because this is open, so some not people also try to join and do some disturbance. So I just remove them from here. Let me see if anything is happening again. All right. So I was trying to say, let's suppose my branch is connected here, and this branch is going to connect via the MPLS, and this is also going to connect to the my data center. Who is the hell again? Some is trying to disturb again and again. Let me guys log this meeting. Okay, so nobody else can join again. So some are trying to do some kind of the. So let me log this meeting. Okay. So now no one else can join. So now you guys can be stay here and no new people can join. So you can unmute yourself and now talk. So I remove the all unwanted people who trying to make some kind of the disturbance. I don't know why they are doing, but anyhow, let's do that our session. Okay, so I'm
Hello.
audible. Mukesh, I'm audible, right?
Yes. What do
Okay,
come
okay.
for?
So
Who are these person?
I don't know. These people sometimes join, so
Oh
they are
my
the funny
God.
people. Okay, so they
Okay.
just having a very time pass kind of the stuff. So no worry. Okay, so they people
Okay.
sometimes join and do sometime naughty stuff. It's
Okay. Thank
happening.
you.
Yeah, no worries. I log this meeting, so no other people can join now. So there will be no disturbance. So let's enjoy our session. So now I am talking right. So let's suppose this is my the MPLS, and this is going to be connected with data center, and this is my the another branch which is also going to connect with the MPLS, right? And this is also going to connect to data center. This is my the another branch. This is also going to connect with the MPLS. This is also going to connect to data center. This could be the one cloud. I have another cloud that could be my internet based cloud. So this is also going to be here, right? So this is my internet based cloud. So my branch could be connected from this branch location to internet, this and this, right? And this is also going to connect to a data center. So there could be the two routers. One is the R2, one could be the R1. So how my traffic is going from one location to another location? So my traffic is going via branch 1, 2 via MPLS, or 2 via the internet to my data center location. If one link going down, then another link is going to come in a picture. But here we are going to use the MPLS, which having the very high cost, but we having the dedicated circuit from the one location to another locations. And when we going to use the internet, which having the low cost. So low cost, then again we are using the shared media. So shared media is something where we have to, deploy some kind of the security parameters. Else our data won't be secure while traveling from the one branch to the data center, one branch to another branch. So there is a various way to make this security. That is the you can deploy the IPsec tunnel. You can deploy the IPsec tunnel. You can deploy the DMVPN. This is the most common and usual. So these are the two method we can use, or GRE we can use over IPsec, right? So these are the three method we can use to make the secure connectivity from the branch location to data center. But as I mentioned, this was a traditional way. So my branch can talk via data center, or my branch can talk directly branch to branch via the IPsec or via the MPLS. This is the way how it is going to happen. But let's think, earlier you just hosting all application in a data center. But now in latest and modern network, we having a lot of cloud service provider. Means we having the Azure, we having the AWS, just I'm giving the example, right? And we having a GCP. And also you are using some SaaS based application. So what is SaaS based application? SaaS based application, that means they are going to, just you can write here SaaS application like O365, right? Dropbox, right? You might be you going to use like that is Salesforce. So we are having a lot of SaaS based application available, and by using this SaaS based application also we have to access. So now I think this branch, one of the user, just think about one user is sitting here, and this user having a requirement to access some data center based application. Might be your SAP server is hosted in the data center. Same time, the same user is wanted to access some servers or some application which is hosted in the Azure part, right? So might be you having some kind of the internal application which is hosted in the Azure cloud. You might be having some application who is hosted in the AWS cloud, some are the GCP. You wanted to access O365. So varieties of the application means we have to use the variety of the application which is hosted in a different locations. So my this network is not enough to access this all application. If I want to make this accessibility, so there is a two possibility. Either I have to extend my MPLS connection till here to here, or my internet connection till here to here. This is the way I can do that. This is the one way. Or similarly, I will extend this all connection. So when you start extending, it is going to, use a huge cost for you. It is going to use a huge cost to you because you have to pay a lot for the providers. Not only the providers, also you have to do your on-site configurations. Your on-site configuration, you have to do that. So that is another problem. So I mean to say, if you want to do that all, so you have to do a lot of connectivity, either from the data center side, either from the branch location side, or you might be you have to do from the cloud provider side. So if let's suppose you are not using the MPLS and you are wanted to use the internet, so you have to build the IPsec tunnel to the cloud providers routers. So again, this is the going to add a lot of complexity. So this is the reason the modern requirement of the network is not capable to handle with the help of the old WAN solution. This network was not that much capable to handle this all solution. So that's why we have to use something which is capable to handle this all kind of the requirement, which is capable to handle that all requirement. So that's why SD-WAN come in a picture. That's why SD-WAN come in a picture. So in this SD-WAN, because nowadays traffic user moving some the branch location to the multiple data center, right? So we required some kind of the architecture which is basically actually it is inherited by this, your legacy WAN only, but the mode of the working is completely changed. And how it is going to be changed, let me explain. So let me just remove this all, and then I'll explain how it is going to be look like in the new network. So in the new network, what is going to happen? So let's suppose this is my one of the router. Understand this carefully. So actual SD-WAN solution is started from this router itself. This is my legacy router. This is not something new. This is my legacy router itself. So in this legacy router, what is going to happen? We having a three planes. One is the control plane. Another is a IO module, and another is the switch fabric. This IO module, you can think about the data plane as well, which called input output module, right? So how the communication is going to happen in this normal routing scenario? Let's suppose this is a router and you want to talk. So what is going to be happen? So let's suppose this is one PC. This PC having some IP address. Just think about this PC having IP address 10.10.10.10/24. This connected with the switch. This PC connected, and this switch is connected on this port. This is the port connected with this switch. I have another switch here. This is another switch. This is connected with this port, and this having another PC connected here, right? This PC connected here, PC2, which having the IP address 20.20.20.20/24. So these are the two PC. So I have the source IP address, I have the destination IP address. So this PC1 want to communicate with the PC2. So how the communication is going to happen with the help of this router, right? And the same thing, how it is going to happen with the help of the SD-WAN solution. We have to understand this concept first. So let's say suppose my PC initiated, I want to talk with this destination. So one packet is going to form here. So let me just draw one packet. So one packet is going to form here, this IP packet, and this packet having a two set of the information. One is the source IP address and one is the destination IP address. So this is my destination IP address. And source IP address we having a 10.10.10.10, but destination IP address 20.20.20.20. So this is the source and destination IP address we have. So once we have the source IP address, once we have the destination IP address, so the packet is going to punt on this particular interface via the physical wire, because this is the physical connectivity. So my packet is going to punt on this interface, which is known as the input output module. So when the packet is going to receive on this particular physical interface, that means you are receiving the packet is input for the router, right? So once this packet received by the physical hardware, that is a data plane, he need to understand how I should forward this package to this destination, because router needs to forward the packet to the destination, but this device interface where the packet landed, it doesn't have the brain. This interface not having any brain, how I can forward this traffic to destination? So he need to consult the brain. So what is the brain? So brain is your control plane. See, this is your brain. The router having the brain, this is the brain, and this control plane having a table that is known as the routing table. Let me just write in different ways. So this having the brain, and this brain having the table that is known as a routing table. So let's suppose this is my routing table. So this is my routing table, and this routing table, you having some kind of the entry. If you want to go on the destination subnet 20.20.20.0/24, your next hop would be via any routing protocol, via the might be any like the like G0. I'm just writing just to make you understand, or any next hop IP address could be also, right? So this kind of the entry could be there. Also there would be the entry 10.10.10 sorry 0/24. Next hop might be you having that G0/0. So these two interface I have, and this routing table is going to build with the help of the routing protocol. So your routing protocol is going to be come in a picture. Routing protocol, this routing protocol could be your static routing, static OSPF, EIGRP, you could be the BGP, you could be you can use the RIP, etc. Right? So this could be your routing protocols. So based on the routing protocols, your brain having some entry, and those entry is going to come in effect when you are going to consult your brain. So you can see this small hardware having a three component. This small hardware having a three component. One is the IO module, one is the brain, that is a control plane, and one is the switch fabric. So if this interface want to communicate with the brain, it have to go first the back plane where the switch fabric is available. Means the switch fabric is nothing, it's just doing the some interconnection between the control plane and data plane. So let's suppose this is my control plane and this is my data plane, right? And they want to talk to each other, so there is some mediator. So this mediator is nothing. This is the switch fabric. So this is my switch fabric. So this switch fabric is something where I'm trying to like connect two plane together. So these are the in the physical boxes. These are the nothing. These are the ASICs. So these are the ASICs. So if you're trying to join via the ASICs, your card are going to insert it like the your control plane card and data plane. They are both are going to connect to the back plane, and they are connect with the all hardware component, and they make one complete set of the logical connections. So my packet is going via the switch fabric. They are going to land in the control plane and going to give, hey, control plane, can you just tell me how to go out to this destination IP address? Because routing is always going to check based on the destination IP address. So this routing table, which is the brain, is going to give the instruction. If you want to communicate with this destination, you go via this interface. So once the instruction is going to be received for this particular packet from the data plane to control plane, then your packet is going to forward it directly to the destination. So this is how it is going to be happen. So your packet is directly going to forward it to the destination, right? Similarly, if we want to talk, the packet is going to reverse, and then again it is going to be reached via the switch fabric, and then it is going to be the brain, that is a control plane, and then it is going to reach to destination. So this is how basic logical packet flow is going to happen when you want to make the communication from the one source to another destination via the router. So this is the nothing. Your all legacy WAN, basically they use the routers. So this router basically are going to use in this way. So all legacy WAN are going to use the router, and these router are going to do the same logic. But if I want to use the same thing in my SD-WAN, then how it is going to happen? Any question, guys, till here? Anyone having any doubt? I hope you guys are able to unmute yourself. Anyone having any question?
So that's all about the before is the legacy WAN.
Yes, this is the concept about the legacy WAN, how the communication is going to happen from the one source to another destination. If you are going to process via the router, this is how the processing is going to happen from the router, and the router is just going to do the routing. Okay. All right. So if I want to use the same concept for the SD-WAN, then how it is going to happen? So this is the known as the closed box architecture. Means your all communication is happening within the single box, right? So SD-WAN is going to leverage the same concept, exactly same concept, but the box is going to be opened. It's not a closed box. This is an open box solution, for which we call the decoupling the legacy WAN architecture and making as the distributed kind of deployment. So when we start decoupling, start breaking this closed box architecture, and we want to make that a distributed architecture, that's become the SD-WAN. But the core concept is going to be same. What I am going to explain, it is going to remain same. In the SD-WAN architecture also, we require this switch fabric, we require this control plane, we require this IO module. Everything is going to be required. It's not like it is not going to be required. Everything is going to be required. The only difference is going to be happen. This box is not longer a closed box. This is going to be a open box. Completely it is going to be open. So how it is going to happen? Understand carefully. So the next architecture I am going to show you, that is a SD-WAN architecture. And this architecture also having a 3 planes. You can see here. Again, I have the control plane. You can see here. Again, I have the switch fabric. Again, I have the IO module, that is a data plane. So these concepts are remain same here, but the way of working is going to be changed. So let's suppose in IO module, I have the same scenario. Again, I have the one switch. Let's suppose this is the router. This router is connected with the one of the switch. This is my switch, right? Let's think one port. This is another port of the router. This is connected with the another switch. right? This connected with the one PC1, which having the IP address 10.10.10.10/24, and they want to communicate with another IP. This is /24. So again, my packet is going to form here. So this packet is going to form which having the source IP address, right? Source IP address, destination IP address 20, 20, 20, 20, and the 10, 10, 10, and 10. So this is the source and destination IP address I have. So in this case, how the communication is going to happen? Again, my packet is going to receive from the PC and it is going to punt to your edge router, which is the SD-WAN router. So if you see the VH is the edge router is the SD-WAN router. We'll discuss in detail what is the edge, VH, what is the CH. But just understand the core concept. Your packet is going to land on this particular router. This might be the GE 0/0 and wanted to leave via the interface GE 0/1. So this is my source IP address which want to go to the destination IP address. Then how the communication is going to happen? So again, this is the IO module. So this router doesn't have in the brain. This doesn't having the brain. This is a data plane. The brain is not available here. The brain is not available here. So they need to go on the control plane device where we have the brains. So again, required some mediator. Again, we required some kind of the device who is going to, stretch the communication from the source to destination via the switch fabric. So in this scenario, the router are located on the site. But I told in the previous yesterday discussion, in every SD-WAN router, the brain is not available. The brain has been removed and put some central location. Yesterday I told, right? So all brain is going to put in the central location from the router. So the router doesn't capability to take the routing decision. So if he want to talk to this destination, he need to consult the brain. Hey brain, can you tell me how can I reach to destination? How can I reach to the destination? Then brain is going to reply, you want to reach to destination, then you go via this way. So brain here also having the routing table. So this also having the routing table. This routing table having the entry. How from this source to this destination you can reach. From this destination to this source, how you can reach. So this all are available in the brain. So the routing engine is not inside the router. That is the outside the router and located somewhere else. So your router will need to connect with the brain via the switch fabric. And this switch fabric this time is not the ASICs. This time these are the not ASICs. They are your service provider, right? Service provider. So what is service provider? Like the ISP, internet service provider. This could be the MPLS. This could be their broadband internet. This could be their 4G LTE. So these all are going to connect with this, edge router, and then further this edge router is going to connect to this ISP is going to connect with the brains. So they are going to do the back and forth communication from the source to destination and destination to source via help of this switch fabric. So in this architecture, SD-WAN architecture, this switch fabric is your ISP, and then you are going to get the information from that, your WAN solution from the site point of view to get the routing from the routing table, which is located in your data center. Any question here, guys? How the decouple has been happened and what is the meaning of this closed box architecture? Any open question anyone have? Please feel free to ask.
I have a small question.
Yes, Pratap, please.
The edge location and the routing table would be in the same place, right? Same data
Edge,
center.
you mean the SD-WAN architecture you are asking?
Yeah, SD-WAN architecture, yes.
So the router doesn't have technically the routing table. The routing table router will get from some controllers. So this is going to keep the routing table in their memory. but it is not self-generated. It is generated by and given by some control plane device. That is a vSmart.
Okay, NV something network virtual appliance something we use for the routing.
Not a network virtual appliance. It's partially correct, but there is one component which going to be deployed in the network virtual appliance. That is a vSmart. That is a control plane device, which I'm going to discuss after that.
Okay.
So there is a component we have that is a vSmart, vManage, we have the vBond, that is a vEdge. So vSmart is the control plane device, which is responsible to basically exchange the routing information to vEdge devices.
Okay. So fabric is nothing but a connections from the IS provider.
Yes, that's 100% correct. So fabric is nothing. Switch fabric is nothing. It's just making the connection. There are the control plane devices. There is three component vManage, vBond. You can see here. So these are the component. Like we have the vManage, we having the vSmart, we having that vBond. It is not written here. Probably we'll find in the different slide. Let me show you. So this is the control plane. This is the devices. So we having the vManage, we have the vSmart, we having the vEdge. So vEdge is always going to stay here, okay? And in between we having the ISP, which is going to make the connection to the controllers, right? So once you want to make the connection from this location to the controllers, that middle part is known as the switch fabric. It's having the just responsibility to make connection from the device to the controller.
Okay.
All right, any other question anyone have?
Yeah.
Yeah.
My question is, hello.
Yes, please.
Yeah, sometime in the interview ask the question like if we are the talk about the SD-WAN new architecture, here we are the connecting to the controller to the our data plane via the switch fabric, and the switch fabric which will be the ISP. So we get the latency issue or something like is the different from the before we are using the legacy WAN type architecture. So how we can replace how you can remove this latency issue?
Yeah, that's a really good question. I was about to come and you steal my word from mouth. So that's a really good question, right? So earlier, uh, earlier, uh, my processing was happening within the box. Means if I want to get routing information, if I want to communicate from any source to destination, so simply I have to process everything within the box, right? I don't have to go out of the box. So it's always a fast processing. Anything I'm going and it is going to back and forth, it is always going to be very fast processing. So if I'm going to put my control plane routing information somewhere remote, might be I'm in India and going to put in the US. So there is a chance have the very high latency. There is always chance. So why should I use that? That's a really good question in the interview. So this is the region. This is the region in before 2014, 15, 16 or early of 2000, 2005. This SDN concept was not successful. This was the region. Latency was the region. They built the blueprint, but this was not a very good, successful, solution. Why? Because that time our MPLS was too much costly, and you have to pay a lot if you want to get the reliable connection. And internet's connection was like the worst. Like if you remember, guys, internet, if you want to download earlier movie, if you can recall, it was like taking a longer period of time. If you going to get 10 Mbps circuits, it's like the very good circuit. People are very happy with the even 2 Mbps circuit for the internet as well. But now we're having a circuit like the 1 gig circuits of the internet, right? 1 Gbps. Even more than that, we are getting right now. Normal like we are getting like the 400 Mbps circuit like the internet. So these circuits are the very high speed circuits. And trust me, nowadays our internet is very much reliable, very much reliable. So if earlier my internet was not reliable, so that's why we having the latency issue. And closed box architecture was the like popular, and that was the successful architecture. But now if my latency is like very optimal, like the very less, so there is no issue. So my ISP internet circuit, even the 4G LTE circuits are superb right now. So they're having the lot of high speed circuits available with the low latency. Service providers are giving those kind of the circuits, likewise the MPLS, and you can use them, and you can reach to the controller to get information within the your service level agreement. So there, that's why latency is not become a big issue for you. But yes, definitely if there is a issue in the circuit and you want to reach in the controller, and then you'll get some kind of the issue. But that's why our ISP are very reliable, and they are very working hard to just make this maintain this latency part. So that's why we can say that they are the okay to use, or they are good to use. Okay, you understand? So
Yes,
most, yes, the most
100%.
important part, yeah, that is the latency due to the high speed circuits available in the market.
Okay.
Any other
Okay.
question? Okay, shall I move next? All right, so let me move next. So we understand closed box architecture, open box architecture. Now let me talk about benefits of the SD-WAN and problem in the legacy WAN. We just have to understand now. So as I mentioned that, let's just suppose we having a few tasks. I'm just giving the very real-time examples. We having a few tasks, and I hope you guys are doing that. And what are those tasks? You working for the NOC, you working for the implementation team, and someone asked to upgrade the iOS for the routers. Router iOS upgradations, right? So you have to do this activity. If you want to do this activity, how it is going to happen? We have to understand this all. So if you want to do this activity, you have to do various kind of the checks, and various type of a dependency is going to require, right? First, you have to download the iOS download required in the local system or somewhere in the data center, right? That going to be required. Second, you require some TFTP server, or might be the WinSAP server, or any other file transfer method you required, right? Someone is going to require on site, right? So on site technician is going to required, right? So if field engineer is going to required with the hardware, laptop, and console cable, right? Then what else is going to be required? You have to require the console cable and all to just connect, and then you have to transfer this connectivity, means the file, not console cable, RJ45 cable is also going to work for you. And then this all going to be upgraded. So I'm just talking about the one device, and one device we just have to download the iOS, require a TFTP, require the RJ45 cable, right? And also we have to transfer the file, then we just have to upgrade it. So we have just one router, then that much effort is going to required. But let's suppose you're having 100 router. So again, this effort is very high, because every device need to be upgraded via the this all kind of the software upgradation one by one with the maximum resource utilization. But if the same thing I want to do for the SD-WAN, the same thing I want to do for the SD-WAN router, so it's just one click. It's just one click. I will show you later stage how it is going to be one click, because the lab is not fully configured. So we'll do from the scratch. But we just have to log into the vManage, and after logging to the vManage, we having the all devices showing in the vManage. All devices is going to show in the vManage, and we just have to go in the software upgradation process. There is an option, and we just we have to select the all devices, and my iOS is available in my this vmanage. We can just click and the upgrade is going to happen and device is going to reboot and the new iOS is coming in fact. So this is how vmanage is going to come in a picture, and that is just going to deploy and upgrade the new iOS in the one single click. But in this legacy WAN, we have to put lot of effort. We have to arrange lot of resources to just upgrade it in this process. So do you guys think this is going to lower down your complexity? This is just one single example I'm giving. This is the going to lower down your single complexity, because you just have to use single click and just it is going to be upgraded. Also at the same time it is going to reduce your cost, because one engineer going to deploy 100 routers iOS upgradation from the vmanage, where if you are going to use the legacy WAN, that is required the 15 of engineer, might be the 10 of the engineers from different shifts. So then it is going to be deployed. So anyhow, your cost is going to reduce, complexity is going to be less down. Another example I'm just giving in this way. Let's suppose I have some kind of the scenario in this way. This is my R1, right? This is my R2. This is connected with the switch. This is connected in this way. And there is a multiple clients are connected in here, right? And I have the ISP here. This is my the MPLS connection, and this could be the internet, right? And we having, let's suppose they are connected with a data center in somewhere. So you just think about this my DC network. So they both are connected in DC as well, and we having the final internet breakout from here, because the firewall is going to come in a picture here. So somehow this is connected in the firewall, and this is the internet breakout, not local breakout. So this is my normal WAN scenario. It's running eBGP here, right? Also running the eBGP here. Here I'm running the OSPF and also HSRP for the first hop redundancy protocol. So for the LAN point of view, my traffic is always going, this PC traffic always going to land on this router, either on this router, because the HSRP priority is high. So just suppose this is the active router. So always traffic is going to land here, and this is my backup traffic. In backup means HSRP backup or a standby, you can just think about it. So my traffic is going to land here, and if this link goes down, then my traffic is going to be, if I'm doing the HSRP WAN tracking and all, so this is going to fail over automatically from here to here, and then your traffic from this PC start going this way to the data center via the internet, because you are using some backup solution to just go via the IPsec and all, right? So this is the one way. In the same way, if this router goes down, again the failover is going to happen. This switch LAN port is going to down, again the failover is going to happen. Your WAN is going to down, again failover is going to happen. So in normal scenario, if any failure is going to happen, your failover is going to happen. But I'm going to give some different scenario now. I'm going to tell you my WAN is not down, but my link performance is degraded. And what is happened? There is a packet loss. There is a packet loss. There is a high latency. So how the failover is going to happen? Anyone? Do you have any way to do this failover? My router is up. This link is up. This link is also up. This link is also up. So is it possible if I have the latency and some kind of the packet loss, my traffic is going to be failover on the secondary link? I believe in the ideal scenario, answer is no. We all agree? Then how the user experience is going to be happen? This user start shouting, hey, I'm trying to access the XYZ application, which is hosted in data center, but this application is slow for me. This user also starts saying this application is slow for me. So if my application is getting slow, then my performance, my business is getting disturbed. Might be I'm in the bank, I'm trying to do transitions, right? I'm in bank, I want to do some kind of transitions. Means some customer are in the queue. But due to this issue, my transitions stop getting, my transition start getting failed. I'm in the MACD shop. I want to purchase the pizza, right? And the transition is not happening because the latency is high. The transition is getting failed. It's taking longer time. So the situation could be hazardous, right? So people will start shouting, start complaining, hey, what you are doing? Your internet is not working. They start getting frustrated. Similar, this user start going to do because their operation is going to be affected. So what is going to happen? There is a NOC who is responsible to manage this routers. So network operation center. This user is going to log a case to the NOC. This NOC having the level 1 engineer, this is the level 2 engineer and level 3 engineers. Right? Very practical. We have this kind of the level 1, level 2 and level 3 engineers. So this level 1 engineer will see, hey, there is some problem. I want to troubleshoot, but I'm not able to fix. So he is going to escalate this case to level 2 engineer. Level 2 engineer is going to check, and after checking, he found my router is up, my link is up, but there is a latency. Then he need to do failover. And this failover is the not auto, because auto failover only triggered when we configured the WAN tracking, router down, LAN down. Then in that case, it is going to be fail. There is IPSLA tracking also. We can do that for some kind of the tweaking, but it is going to add a lot of complexity. It's going to flap the link. The performance is going to back and forth from primary to secondary. So that is not also a stable solution. But we can apply even the latency tracking as well. So in that scenario, L2 engineer is going to do the failover manually. He will first very good knowledge of the BGP, very good knowledge of the OSPF, very good knowledge of the HSRP, how the traffic is redistributed, how HSRP priority. Then only he can do the successful failover from primary to secondary. If he have not very good knowledge, either of the section, either the BGP, OSPF and HSRP, he might be struggle and he will fail to do the failover. And it is going to lead another escalation. And this is a practical I'm telling because it's keep happening in the real infrastructure network whenever people are not too much skilled to do such kind of the activities. So probably L2 is going to consult with the L3. Hey L3, can you please help me to this failover? So it is going to time taking job. At least 1 or 2 hour it is going to take, or sometime good engineer can do 30 minutes and 15 minutes if he having the very good understanding. But it is time taking job. So once you do the failover, all services is going to shift on the R2, and via R2 all start working via the data center. User become happy. Here user become happy. Now issue has been resolved, and they are start doing the all business operations. And now you log a case with ISP here. ISP, you log a case, and ISP start working for you, and they will fix this issue within the SLA. And once issue has been fixed, again you have to do the rollback of the changes. It's not the automatic is going to happen, because once the issue has been fixed, because you tune the HSRP configuration, BGP configuration, OSPF configuration, so again you have to roll back the changes so that my traffic start going normal via the primary link. Understand? So this entire operation itself is the complex. Skill is too much is going to require. But just think, this is not a normal router. This is the legacy router. Sorry, this is the SD-WAN router. Then how it is going to be happen? just replace this all via the SD-WAN router to legacy router, to SD-WAN router, then how things is going to work. So you just connect to SD-WAN router here, that is a VH1, and you can connect the VH2. The same scenario, you are running the here, not HSRP, you can run the VRRP, you can run the OSPF again here, right? And they are connected with the MPLS, right? And they are going to build the IPsec tunnel. So underlay, you can use the BGP static, whatever you want to use the underlay. Static route, you can use BGP use here to just make the underlay connectivity. Either of you can use, but while building this data center, like the all communication, they build the tunnels, that is IPsec tunnel. We'll discuss how it is going to build, but just understand. Now I have the same problem. My link is up. This link is also up. This link is also up, right? This router is also up, and this is my PRRP. So this is my the primary, and this is my the backup, right? So in that case, if the LAN traffic is going to come from this my primary, from the LAN traffic is going to land to my primary router. Primary router basically going to do all the processing, and the traffic is going to send the data center. But if there is a latency here, there is latency, then this user will never become sad if you're using the SD-WAN. If there is a latency, you don't have to reach out to NOC as well. You don't need to reach the NOC, L1, L2 and all. What is going to happen? This router automatically ship the traffic to the secondary link. This is going to happen automatically. Means auto failover is going to happen. This all auto. How it is going to happen, I'll tell in the practical. So this is the auto failover is going to happen. Means the traffic from the primary to secondary automatically going to shift it. Once the latency is going to be high, your loss is going to be high, and if you're using the SD-WAN, no manual intervention is going to be required. This is the beauty of the SD-WAN. So it is just avoiding all complexity. It is just avoiding all the complexity. It's making your life easy, right? And you having the predictable application experience, and at the same time when the traffic is shifting on the primary or secondary link, you having some kind of report and data about the link, how basically my traffic is going via which link, and what is the performance of the traffic, what is the performance of the link, and this all is going to be happen. So this is my another case of the example. Second thing, if I am using the legacy WAN, right, and I want to do some routing, so routing always going to happen based on the destination address, either IPv4 or IPv6. This is the only true way I can do the routing. But if I am going to use the SD-WAN, I have the privilege, I can do the routing based on the application. So what application is that? If I want to do the routing, I can do the routing based on the WhatsApp application. Very interesting, right? I can do the routing based on the YouTube application. No destination address. It's the based on the application. I can do the Instagram based application. I can do Teams based application. Teams, Office 365. So these many more we have. These application I want to send WhatsApp traffic via this link. I can do. All WhatsApp is going to via this. I want to send YouTube via this. I can send the YouTube via this. I can send the Instagram from this. I can send it this. Teams traffic here. So I can send via here. So there is no destination. Based on the application, I can do the routing as well. And you can, in case of any failure, they are going to auto shift from primary to secondary, secondary to primary. This is also application aware routing. So this is the beauty of this SD-WAN. In legacy WAN, if I want to do the routing, you have to use the destination base. Either you have to default route, at a one time, one router will send the all internet traffic, or you should know all the WhatsApp destination IP address. Either you have to know all the WhatsApp destination IP address, then you can do the routing, and they are very dynamic. WhatsApp, Google IP keep getting changed, so it's very hard to gather those IP information. So better you use the application aware routing. So this is another beauty of this SD-WAN solution. I hope you guys are getting me right. We having
Yes,
the yes, please.
yes, got it. Thank you.
Yes, thank you. Another great feature we having a zero touch provisioning. So let me just give the live examples how it is going to happen. So let's say suppose what does mean zero touch provisioning? It's a very unique feature we having the ZTP, that is a zero touch provisioning. So let's suppose I have the one of the legacy router here, right? And I hope you guys are very familiar. This is the one of the router that is a normal Cisco router. It is connected this. For some reason, this router got faulty, right? For some reason, this router got faulty. Then what is going to be happen? You have to raise the RMA with the Cisco. RMA is required. After getting the RMA request, router is reached to the site. It required the field engineer. This field engineer required the config backup. Because without config backup, how the router is going to configure? They need to involve the NOC engineer who is going to do the remote configuration, right? They have to arrange the console cable, right? They have to connect the LAN WAN cable. They have to connect the power supply. This all going to be required. Without this all, your configuration is not possible for the router, right? Your router replacement should be asked to the Cisco, and they are going to send the router on the site. Once router is on site, you have to arrange the field engineer who can reach to the site, who can mount the router, who can connect the LAN and WAN and apply the power supply. Then you have to approach to NOC engineer. Hey, NOC engineer, can you give me the running configuration of this device so I can configure it? So you have to pull out the backup configuration, and after pulling out the backup configuration, you can do via the WebEx or Teams or Zoom to just router remotely, or field engineer can do the locally. So this is sorry, this is how this router configuration is going to be happen. But if your SD-WAN router is going to be down, so what step is going to require? You require the RMA. That definitely is going to require the RMA with the Cisco. Someone not FE, not very technical, any local IT people who can connect the LAN and WAN cable, and third step, just do the power supply. That's 3 step only. Anyone, either FE or the local IT people. So other step is not required. Not require the config backup. Not required the console cable, laptop that you have to do the remote connection. Nothing is required. Just mount the router, connect the LAN cable and WAN cable. Router configuration is done. All config is done automatically. Not magic. And how it is going to happen? That is zero touch provisioning. We'll discuss. We having a dedicated module for this zero touch provisioning, right? We'll discuss how this zero touch provisioning is going to happen. So we'll have the very detailed way JTP process. So we'll understand in later section how this is going to be happen step by step. So there is a multiple steps how it is going to happen. Not going to explain, but you have to understand this zero touch provisioning in SD-WAN. It's giving the option by just plugging the router on the LAN and WAN cable and just providing the power supply. It's going to automatically configure. You don't have to do anything, and that is going to serve your network. See, this kind of the magic we have. So you are saving a lot time or lost cost by using this SD-WAN solution. Zero trust fabric. What does means zero trust fabric? So let's say suppose I have the fabric. Which fabric? Let me show you. So if I'm talking about the fabric, so fabric is nothing. Fabric is just, interconnection of this all devices via the edge location, via the cloud means the control plane location and the intermediate devices. So you just think about in this topology, I have the one vManage, one vSmart, and the multiple VS devices. So they all are connected each other. So they build one fabric, means they are interconnected to each other. So what is the zero trust fabric? So zero trust fabric mean, let's suppose I want to onboard a new VH router. I want to onboard, I want to connect this fabric. So before it is going to connect this fabric, it have to prove their identity. It have to prove their identity, whether I am the valid or not. If I am unable to prove my identity, probably I am not able to join this. So how identity proof is going to happen? There is a several steps. How every credential is going to, let's suppose you have to join any company. So first you're having the offer letter, right? And you will reach to the office reception. Then someone is going to validate your identity first. And after validating your identity, they will validate your offer letter. And then they will complete your joining formality, and then they will introduce you to your manager. Simple, right? Then your manager will come in a picture, because once you make HR happy with the all documentation part. So this is a zero trust, means before you are going to part of the company, even you are having the offer letter, you have to prove your all identity. Then you are part of the organization. Similarly, in the SD-WAN, zero trust fabric concept means any device, either the vManage, vSmart, vBond, vEdge, CH, if you want to join the fabric, you have to prove your identity. It's not like someone is coming and join the fabric. Earlier, it was not such kind of the validation in the legacy WAN. If you want to join any router in the network, you can just connect and just do the reachability. They will join the network. Just you have to make the reachability. But here, no. Even you make the reachability, but reachability is there, but your identity is not like proof. You cannot communicate to the all branch location. So this is my zero trust fabric. Okay. Application aware, we understand. Intent based networking. What is the intent based networking? So in SD-WAN solution, we having the flexibility based on my intent, based on my wishes. I can do some manipulation. I want to send the traffic, like I want to send some traffic via this router. I can do. I want to send some WhatsApp traffic via this router. Suppose this is the edge router again. I can send WhatsApp traffic this way, Instagram traffic this way. I can validate some kind of the DIA based connection. I can send the SaaS based application traffic. So I have a lot of flexibility. I can do a lot of modification based on my intent, which earlier was not there. I have a lot of option available. I can do traffic manipulations based on my intents. That's why intent based networking, right? I'll show you how it is going to happen. Reduce cost, we understand. Improve performance. So definitely the performance is going to be improved anyhow, because that much benefits we have. So anyone have any question? These all benefits of the SD-WAN. You guys are able to correlate. Later stage will prove everything how it is going to happen in the labs, because we have to go very long way to understand these all concept. But meanwhile, anyone having any questions? Because I have done, because initially a lot of theory we have to understand. So I believe that's all from my side for today. But if you have anything to ask, please feel free to ask. I have few questions from the social media platform. Abhijit Sirsikar is asking the question: what is the duration of the traffic shifting? So Abhijit, so duration of the traffic shifting is a very fast based on the your if you're doing that shifting based on the LAN. So whatever the VRRP timers, based on the timers, 1 to 3 seconds, we have the timers default. Based on that, they are going to shift the traffic from the LAN to one router to another router. So this is the how traffic shifting is going to happen. WAN failure, that's again the very quicker. WAN failure is even going to happen, then your LAN traffic is going to shift based on your VRRP timers, right? So this is the traffic shifting is going to be happen from the one link to another link, or one router to another router. How the second question is asking how it will be identify the vEdge in the network. So definitely you have to identify, because the vManage dashboard, we have to log in, and after login we'll configure step by step. Then in this vManage you will see which all vEdge network are live, they are showing in the vManage dashboard. If they are down, they are showing in the down. If they are up, they are showing in the green. So I'll show you how it is going to look like, then you can understand your vEdge is up and working. The third question is asking, the routing discovery or network discovery is the one-time process or it's a periodic? No, routing discovery, network discovery is a one-time process, unless or until there is a change in networks. They are the one-time process. That's all. Good morning, Nature. Yes. So I believe this is the three question Abhijit asked me. So I try to answer. Yeah. Anyone have any other question to discuss today?
Yes, sir, Firoz here.
Yes, Priyoj. Good morning. Tell me.
Good morning, sir. Yes, sir. Sir, I have some doubts. Sir, we are taking two ISP link. One is the MPLS and one is the internet link.
Mm-hmm.
So I think MPLS link is costly compared to internet links. And you also shared something like IPsec kernel and other DM VPN, other applications are like other type of the security we have to apply. So I have doubts, sir, ki in MPLS and what is the difference like MPLS and internet link and how that will be costly and cheap of that, and which link is data is secure and like this type of things.
That's a good question. Okay. So let me answer you. So first you have to understand how MPLS link work. Okay. And what is MPLS? Okay. So if you want to understand the MPLS, so MPLS is something, let's suppose this is one of the branch location. This is the branch one, and this is your data center, DC. This is in the USA, and your branch in the Delhi, India, right? Another branch might be the, you can have another branch in Dubai, right? This is the branch 2. Another branch, you having the branch 3 might be the Singapore, right? These all three branch. So if we want to use the MPLS, so there is the MPLS provider cloud will be there. Could be the one, could be the multiple. So MPLS cloud is there. Your router is going to connect to the P router, that is a provider edge router that is located in different POP. So this is the P router. So this is the P router, right? And further, they are going to connect with the one P router, and they are going to connect to DC. So in MPLS, you are running the MP BGP in the cloud providers, and the BGP or in the LAN or in the any other routing protocol also you can use that. So what is going to happen? They are going to provide a dedicated end-to-end circuits. They are going to provide dedicated circuit from here to here, dedicated connection. All dedicated means your communication is going to originate from branch. So this is the cloud. This is the cloud. And in this MPLS cloud, having the millions of customers, might be the 1 million customer, might be the 1,000 customers, right? These customers are using this cloud. But even these customers are using these clouds, like this connection from your point of view, means your branch location point of view, they always going to be private connection. That is known as the MPLS L3 VPN. So they are the L3 VPNs, and they are the private VPNs, means they are having the separate dedicated line for you. From this location to this location, you having the dedicated pipe where you're sending the traffic. Means you just think about from your home to your office, I created one dedicated road. You can only go on this road. No other vehicle is going to be used. So you can think this infra is the private, this private infra. So your home, your office, your car is just running on this road. So this is dedicated for you. But I have another infra. This is your home. This is your office. But this is the normal public road, right? So this infra is not dedicated for you. This infra having the multiple cars are running for the multiple people. So it is not dedicated kind of the stuff. So there is chance someone is going to hit your car. There is chance someone is going to see what you carrying inside your car. But here not. So once you are going to use dedicated, you have to pay more because you are going to use dedicated infra. So you have to pay more. Here you have to pay less because you're just using a shared media. So MPLS is always costly because you have to end-to-end private circuits where your data is confidential. Nobody can understand what data is you sending and receiving. But in the internet, the media is shared. So if the media is shared, so I have to do something so nobody can look. So if I am going in the shared road, so I don't want to expose myself what is inside of my car. So I can might be cover my all my glasses with the black covers. I can do. It's not legal, but I'm just saying telling the examples. I can do those kind of stuffs if I want to do. So for that, in the internet world, if you want to secure, you just have to use the connection security, that is IPsec or the DMVPN. So they are going to secure your connection over the shared media because they are the internet. Internet is everywhere. Everyone is using. So that's why they are the cheap circuits. They're the low cost circuit and they are going to provide the high bandwidth, but you have to use some kind of the third party encryption method. Firoz, make sense?
Yes, sir, got it. That's why, because multiple organization is shifting from MPLS to private network. That's why I'm asking on that key, which security point of view we are using that application to forward the traffic.
Can you come again? I just missed this first part.
No, actually, I want to say you, sir, many organizations is shifting to MPLS to private network because MPLS is a costly net.
No, MPLS is
And
not
we,
private. MPLS to internet. That is the correct one.
no, I'm telling on that, sir. Organization shifted to MPLS to private network. Why? Because MPLS is the too costly and
So
private
what does
is
means a private network, Firoz? Private network means what?
private. It means, sir, like private is like a private ISPs like Airtels or like TCS and this type of the public network we are take on the ISP link. Na, sir? On that time we are telling on that we have to shifting MPLS to private IP. So private IP it's public IP, but private like network like MPLS, sorry, Airtel and other links.
So let me just clarify. There is only two type of network. One is the MPLS, right? You can mute a lot of background noise coming.
Okay, so
One is internet, right? Third one is the LTE. Again, is the part of the internet and 4G. The other network, okay? And this can be you all three can you get from the Airtel, who is a service provider. All three types circuit they can provide. Vodafone also you can take. So ISP having all three products, you can purchase them, okay, based on your need. Likewise, if you want to buy a car from the Tata company or might be the any other company, they sell a truck, they sell car, and they also sell a bus. So based on your requirement, you can purchase the product, but the provider is a Tata only, right? Truck, bus, and car. They all are providing the three kind of service. So these are the ISP provider. They sell the MPLS, internet, and LGS. But MPLS is costly. These are the low cost. You can use this, but when using this, you have to use some kind of encryption method to just secure the connection from the source to destination. That's all. Thanks, Abhijit. Yes, so definitely we'll meet and like continue this session from the upcoming classes? Yeah.
One my quick question, can I?
Yes, please.
Yeah, okay, thank you. So my question is that if any organization using the MPLS link for to connect to the branches or the any data center or LAN environment, the remote LAN environment, so is this required for the any external security for this MP if he is using the MPLS link, because the MPLS is already is the secure tunnel and the secure dedicated link. Is this
Yeah.
required or not?
So I have the one question. You are talking in reference of the SD-WAN or you are talking in the reference of the legacy WAN?
We can talk about in the both scenario. If
Okay.
you can give me the one
So
quick
yeah,
answer.
okay. So in both scenarios, all right. So if you're using the normal WAN solution and if you're using the MPLS, okay, so there is no additional security is required, right? No additional security is going to be required. But if you're using the SD-WAN, still you want to take the MPLS circuit, right? This is not just MPLS circuit. So by default, even if you're using the SD-WAN and MPLS, there is a by default IPsec tunnel is going to be created for the all communication by default. So it is going to be used by default SD-WAN connection IPsec.
But in legacy WAN is the not a tunnel, so we required the any additional tunnel if we
No.
want to
It's
the.
MPLS is always going to build the L3 VPN tunnel, na? So this is L3 VPN tunnel is based on the MPLS. There is no IPsec and all. This is the different concept. MPLS is completely different concept. L3 VPN tunnel is going to build, but here MPLS is going to act as the underlay in SD-WAN, and it's just going to give the basic IPv4 connectivity, and you have to form the overlay where you have to use the IPsec.
Okay, I understand.
Yeah, but here just underlay and overlay same the L3 VPN connection. Ibrahim, you want to ask something?
Yes, I have a question. That's my question. Can you hear me?
Yeah, I can hear you.
Hello?
Yeah, I can hear you.
So you just mentioned overlay and underlay. What is the difference? Well, in what case do we use either of the two?
Okay, so let me explain. It's a good question. We'll discuss, but let me explain. So we having a concept of the underlay and overlay. So underlay, just one line definition, just build the basic IPv4 connectivity. That's underlay. What does mean? Let's suppose this router want to talk with this controller, right? This controller, or this one, or any other router. So before you can start anything SD-WAN fabric communication, first connection, you must be able to ping this public IP address to this public IP address via underlay reachability. That is a basic IPv4 connectivity. So either you are using the BGP in between or static route, whatever the routing protocol you're using. But first you have to make the IPsec means underlay reachability. Once you build the underlay reachability, means you able to ping from here to here, then you can build the overlay tunnels to just make your network intelligence. So the simple examples, everyone is aware about the IPsec tunnel, right? IPsec tunnel. Let's suppose this is R1 and this is the R2. And in between we having the ISP. This is the internet. Basic example. This is connected here and here. And you have to build the IPsec tunnel in between. So what is the first prerequisite? You having the public IP address in this place and also the public IP address this place. The first prerequisite, you must be able to ping this public IP to this public IP address. If you're not able to reach, you cannot form this IPsec tunnel. So to form this IPsec tunnel, you have to make sure your public IP should be reachable. So this public IP address reachability, it always via the static route or the BGP, but you can reach from here to here. That is your underlay, means you are reaching from here to here, ISP. Once you have the reachability, then you can build the GRE tunnel or the IPsec tunnel. That's your overlay. That's a simple difference.
Okay, so okay, thanks for that clarification.
Yeah,
So
welcome.
right now, this means for basic connectivity.
Yes, basic connectivity. That's the
Okay,
basic IP
basic connectivity is the underlay, right?
Yes.
Before you build any tunnel on those two ends, right?
Right,
So
right.
before building the tunnel, it's referred to as the underlay.
Right, right.
So the tunnel you build on either IPsec or GRE over that basic connection to secure that communication is called the overlay.
Yeah, exactly. 100% right, Ibrahim.
All right, thank you.
Welcome.
And
You're welcome.
question
Yeah.
again. So you talk about the MPLS, right? So MPLS has a kind of end-to-end solution for the L3 VPN. So that's what they use for the MPLS. Now,
Right.
if you yes. So does it need to do any encryption on that? So since it's the private network, private solution.
No
Does it
encryption.
need
No encryption
Okay.
with MPLS. No encryption.
No encryption. Okay. So all the data transferred is plain.
Plain.
Since
Because
it's
they're
dedicated.
dedicated. It's a plain. No encryption.
Okay. Okay, thank you. Yeah, that's what I have. And what's the next time? The next class is coming up.
Next Saturday.
What time?
Same time.
Okay.
Next Saturday. Same time. It's going to happen.
My Friday.
Yes, your Friday. Yeah. You'll get the invitation. Okay.
Okay. Okay, yeah, that's what I have. So the next class we're going to start the SD-WAN proper with the lab.
Yes.
because
Yeah.
Yeah,
Next class
because
we'll do the lab configuration. Yeah. Lab configuration will do.
Before we go to that, I don't know, maybe you have a few more seconds before we like all those components, right? I know you mentioned it briefly. All those components, what's the functionality of each of those components, like the vManage, the vBoss, vSmart, and stuff like that. Are we still going to reverse them?
Yes.
In the next class?
Next class,
Okay.
before, let me show you. So you'll get an idea. So in next class, we will understand deeper side of these components. So this is traditional WAN, and then this is your SD-WAN. So we'll understand one by one all the functionality of the every control plane devices and data plane devices. What is the function? So we'll cover officially as the Cisco documentation, and we'll do the deep dive understanding. Then we'll do the lab configuration. So the first objective to understand the first component part in the next class. Still we not touched. Yeah. So everything we'll discuss.
That's okay. Yeah, thanks. That's what I have.
Yeah, thank you so much. So Abhijit is asking like how about the lab setup and access. So Abhijit, we having this lab access, so you can access this remotely. Just you have to access this URL, and after URL accessibility, you just have to put your username and passwords. Everyone will get the username and password. Right now, I'm logging by the admin. So once you log in it, you just have to select the HTML console from here, and HD is the captcha, and then your lab will be the ready, and you can start doing the configuration. This lab can be accessed 24/7 from anywhere. So this is how you can do the lab practice.
Is the lab ready now?
Yes, lab is ready. Lab is ready.
Okay, so how are we going to get the credentials to be able to log in?
Just need to connect with the Abhishek sir. So he will provide all the information.
Okay.
Yeah. All right. So that's all for today, guys. Yeah. See you in the next class. Happy Sunday for everyone. All good.
Okay, thank you so much for the classes and the very good knowledge. And
thank you. Welcome, Mukesh. Welcome everyone. Yeah. I hope you guys enjoy. Okay. So we'll connect in the next session. Okay. Bye-bye. Take care.
All right.